So in this video, I'm going to talk about Java and database. Java programming language exemplify many of the concepts that we have discussed so far. So basically, a Java program classes that execute within a virtual machine we call a Java virtual machine, a JVM. This allows the language to run on any platform for which a virtual machine environment has been written. Basically, Java is just both a compiled and also interpreted language. The output of the compilation process is an assembly like intermediate code, that the bytecode that is interpreted by the Java virtual machine. So here's the basic procedure of the how the Java code gonna be executed. Basically, the Java virtual machine is the an operating system in miniature. So basically, it loads the program, link them, start the execution thread, manage the program resources, and deallocate the resources when the program terminates. So we have the source code right here written in Java language. And then gonna go to the Java compiler. So it's gonna transform the Java source code into the bytecode .class file, and then gonna load into the Java virtual machine. So basically, we have the by verifier class loader and by interpreter in the Java virtual machine. So because of the Java virtual machine perform so many tasks at the runtime, so that gonna make the performance of the programming written in Java cannot match the performance of the traditional compile language such as C or C++, so on. So at the execution time, a Java virtual machine must be running on the whole system. Basically, the JVM gonna load and execute the bytecode of the class file. So while loading the class file, the JVM verify the integrity of the bytecode. The loader then perform a number of runtime checks as it places the bytecode in the memory, and also the loader gonna invoke the bytecode interpreter. So basically, the bytecode interpreter gonna perform 6 tasks. The first one is perform a link edit of the bytecode instruction by asking the loader to supply all the reference classes in the system binary if they are not already loaded into the memory. The second one is that it create and initialize the main stack frame and the local variables. The third one is create and start the execution threads. And then the next one gonna manage the heaps storage, and by the locating unused storage while the thread are executing. So in this case, the unused storage can be reused by the different program. The next one is the locate the resource of terminated threads. So in this case, the resource gonna be free, and other program and other processes can be can use as resources. And the last one, that's the upon program termination, is kill any remaining threads and terminate the Java virtual machine. So that's basically the 6 steps of the bytecode interpreter. So because of the Java virtual machine that so much as it load and execute its bytecode, the performance cannot match the compile language. This is true even when the speed up software like Java just in time compilers is used. That's gonna use to speed up or improve the performance of JVM. However, the class file can be created and stored in one platform and executed in on a completely different platform. So that the benefit of using the Java virtual machine. So that's basically that's a paradigm we can call that the read write once and run anywhere. That's enormous benefit for enterprise where have the disparate and geographically separate system, where we can have the code in one place, but the user maybe run and execute the program in different place and different system. So given its portability and relative ease of use, Java language and its virtual machine environment as the ideal or middleware platform. In the next slide, we're gonna discuss about database software. So basically, the database system contains the most of the variables assets of an enterprise. Basically, they are the foundation upon which the application system are building. So for example, we have the operating system right here, we have the hardware right here, we have some data file right here, and we have the many applications right here using the database in order to perform the task. So that's gonna be need to manage by the database manager. Okay. Database software basically provide a single definition of the database schema for a data element that are accessed by application program. So we have the two concepts of schema. The physical schema is the computer view of the database that includes the location of physical file and indexes. The logical schema is the application program view of the database that define the field size and the data types. Okay, so that the two type of schema from different view. Within the logical schema, certain data fields are designated as the record key, and also that provides the efficient access to the records in the database. The keys are basically stored in the physical index file structure that's containing a pointer to the location of the physical records. Many implementations use the variants of the B+tree for index management because the B+tree can be optimized with the consideration to the I/O system and the application. However, in many cases, the higher node of the tree will persist in the cache memory, so that requires a physical disk access only when the traversing of the lower level of the index. Also, most of the database system also include the transaction management component to assure that the database is always in a consistent state. Basically, the transaction management provides the following property. First one is atomic. That's gonna be all related update occur or no update occur. The second one, that's consistency. That's all updates conform to defined data constraint. The third one, that's isolation. That's no transaction can interfere with the another transaction. And the last one, durability. That's successful update are written to durable media as soon as possible. So they are we call the ACID property of the transaction management. So let's see what is that benefit using this by having this property. So let's consider a scenario. We have the two different users accessing the database. One is a sales collect and the another one account collect. For example, if we don't have the ACID property, we have the race condition can occur. So in this one, both of the user gonna read the information and then they do some kind of operation right here and gonna write back into the database. So you can see at the beginning we have the same information $200 right here, gonna be read into the sales collect right here, and also can be read by the counting clock right here. They do some operation right here, written to 0 right here, and also do some operation and written $300 right here. But however, this one not the thing we want, because we maybe want this one perform first, and then the output of this one gonna be performed by the save click right here. So this one is the make the information in the database incorrect. So now, if we have the assist property, we can ensure that the information gonna be consistent. So because using the assist property, we can see that the record gonna locking until the other one finish. So if this one read the information, the save clicker not allowed to access to the information. That's we need to wait. Just a lock condition right here. So this dual operation right here. Once the information gonna update it into the database, that's gonna be unlock the next request right here. Then this user gonna be locked become into a lock state again. So you can see that 0 right here gonna be read by the save clicker instead of 200 as before. So now they do some operation right here. The information gonna written back into the database. So using the by having the assist property, that's gonna make sure the database are consistent by allowing sharing by multiple users. So that's a basic some information about the database, and we can read more about the information in the textbook.